Consider the sequence that has a first term of 6,561, a second term of 2,187, and a third term of 729. Write the next four terms of this sequence. So if I take my calculator and I, for example, take a number like 729 and I divide it by the term that precedes it, 2,187, I get this value that is 1/3, right? If I could ask the calculator to convert this to a fraction, but it is the number 1/3. So I have this idea that if this holds, if the patterns hold, what I'm doing is I'm multiplying 1/3 to go to each successive term. So I could start, for example, with the first term, 6,561, and I'm going to verify it by multiplying it by this. Can I go up there and get that? I can't. Look at that. Multiplying it by 1/3, and when I do that, I do get the second term, 2,187, and I can multiply that by, let me go up and get the 1/3. Doop. And when I multiply it by 1/3, I get 729. So I need to get the next four terms here, so I'm going to go ahead and just continue this multiplying by 1/3. I'll just say times, I wonder if there's an easier way. I'll just do 1 divided by 3. Good. So I get the next term is going to be 243. Let me put this over here. So I'm looking at 243. The next term after that, I'm going to multiply by 1 divided by 3. I get that's the number 81. And then times 1 divided by 3. That gives me the number 27. Oh, wait a minute. I can divide by 3. Oh, yeah, it's dividing by 3 too, isn't it? And the last one there is 9. Now, my preference is always to think about these terms in sequences in terms of multiplication. It just helps write the explicit sequence. It makes it look better when you write it that way. So the next question here is, what's the generator of this sequence? And I'm going to be real specific. I'm going to multiply by 1/3. Conversely, it would be fine if you said divide by 3, but it's much cleaner, and the preference should be that we're stating these in terms of multiplication. So get in the habit of thinking this. We're multiplying by this 1/3 times 1/3. What kind of sequences is it, and how can you tell? I know this is geometric, and the reason why it's geometric is I can say its terms have a common ratio. Right, we keep multiplying by 1/3. And then finally, the last question is for this part is write the explicit formula for this sequence. So again, for this sequence, I know the first term, and I suppose in order to write the explicit formula, I'm going to want to know what the 0th term is. So let me take again the 6,561, and I'm going to take it, and instead of dividing by 3 or multiplying by 1/3, I'm going to multiply by 3 to get the term that would precede it. So you can see the 0th term there is 19,683. So I know the 0th term is 19,000, so I think I can write this now. It's going to be A of n is the 0th term, 19,683. And then I'm going to be multiplying each time times 1/3, and then I'm going to raise that to the nth power. Now that's there, and I understand that partly because I've paid attention and I've kind of memorized it. But what also is really compelling and convincing to me is I can take my scientific calculator and verify pretty easily that it's giving me the correct values. So a couple ways I can do this. I can take the 19,683 and multiply it by, Let's see, I'm going to open parentheses, and I think on this calculator I can do fraction. Yep, there it is. And I'm just going to go 1 over 3. I like how that looks. And I'll close the parentheses, and I'm going to raise that to the power of. Now I'm just going to keep editing this. So if I put it to the first power, I can see I get exactly the first term, right? It is 6,561. Now if I come back up and grab this whole expression again, and this time I'll edit it so that it's going to evaluate that to the second power. It'll give me the second term in the sequence. It is 2,187, exactly what the second term should be. And I'll just jump ahead and just do, I could do this a long time. This is fun for me. If I put in the number 5, it tells me that the fifth term would have to be the number 81. And I can come back up and look at it. Yeah, this is the first, second, third, fourth. This is indeed the fifth term. It's 81. So again, this explicit formula, right? 19,683 times 1/3 to the nth power. It's nice, but the thing that's nice about it is it's producing the correct results. I can see and I can verify with arithmetic, using my calculator in this case, that it is producing the exact sequence that I'm talking about in this problem.